Okay, using Pythagoras' theorem to solve three-dimensional problems. So right-angle triangles can be identified in many three-dimensional solids. So if you're thinking of like, I don't know, for example, a cylinder, okay, the diagonal along the cylinder here, so basically from like the bottom left corner to the top right, and then if you also use the diameter of the cylinder and one of the side lengths, it actually makes a right-angle triangle. So the toughest part about this topic is actually identifying where the triangles are. So it's important to try and draw any of the identified right angle triangles using a separate diagram. So just like we have here, okay, so here's the 3D shape. You can see the triangle on the inside, but it is better to redraw it again on the outside and then do working on that new triangle. And you'll see me do that in the examples coming up. Other than that, everything else is exactly the same as what we've done. So let's have a look. So example 1, so the question ones, is quite easy. All you have to do is see if the shaded part is a right angle triangle or not. So like you'll look at the triangles, see if they make a right angle triangle. If they do, yep, hooray. If they don't, no. Oh well. They're pretty noticeable though too. So it is effectively, does it look like a right angle? Yes, good, no, don't worry about it. So here's an example of one with it is. So we've got a rectangular prism by the look of that. And what we're going to do is we are going to find the distance, d. So this slant here, so from the bottom left corner up until the right corner there. So it's like, it's the diagonal part from one corner to opposite corner in the rectangular prism. Okay, so we can see that we've got a right angle triangle in there. Okay, so the height of this prism is the 10 centimeters. The length from the diagonal to the diagonal along the bottom is 20. And then the diagonal from top to bottom is what we're trying to find. So I'm going to redraw that triangle just over here, like this. Okay, so here's my right angle triangle. Now it's 20 along the bottom, so I'm going to write 20 centimeters there. It's 10 up the side, so I'm going to do 10 centimeters there. And I don't know what it is there, so I'm going to put d centimeters there. So to find out what the length is of that diagonal, we're going to use Pythagoras. So c squared is equal to a squared plus b squared. Remember, always write that out to begin with. Then we're going to substitute our values in. So my hypotenuse is the side that's opposite the right angled triangle, or the right angle in the right angle triangle. So it's d in this case, so d squared is equal to, now remember it doesn't matter which order I do these ones. So 20 squared plus 10 squared. So d squared is equal to, so 20 squared is equal to 400. 10 squared is equal to 100, so that is equal to 500. So d squared is equal to 500. Remember that's a really big number, so to find just what d is by itself, we're going to take the square root of that 500 there. So the square root of 500, you pop it into your calculator, and we get 20, so d is equal to 22.36 centimeters, and that's rounding it to 2 decimal places. So remember, this value here is the exact value, okay, and this one here is rounded to 2 dp. Now, if it doesn't tell you what to round to, I just use 2 decimal places as sort of like your standstill thing. But yeah, so like it's pretty easy. It's just an application of Pythagoras' theorem again, with shapes that are in 3 dimensions. So example for question 3, find the slant height of the cone, so S, answer correct to 1 decimal place. Okay, so the slant is either this side here or this side here. Okay. So that's the slant there. So it's like it's a sideways, or, you know, like, anyway, we've got S. So we don't know what it is, but we know that this length here is equal to S. Okay, we also know that the cone's diameter is equal to 15. And we know that this value here is the height, so how tall it is from bottom to top. So straight up and down. So not the slant, straight up and down. So if I was to draw that in the middle, it'd go up the middle like that, and that would be 23 millimeters. So now the question becomes, well, how do I how do I solve this problem? So, I need to find where a right angle triangle is. Now, by drawing that 23 millimeters on the inside, we can see that there is a right angle triangle sitting there in the inside. Okay, so I'm going to take that right angle triangle out, and I'm going to draw it. Well, in fact, I'm going to draw it up here. So here's the right angle triangle like that. Not amazing drawing, but still, it's going to make it a lot easier. Now we know it's 23 millimeters along here. We know the slant height is S, but we know that the whole diameter of that cone, so from top to bottom of the diameter, is 15. But we've only got until halfway, so from the edge until the middle of that. So this part along here is not actually 15 millimeters, it's actually half of that, which is 7.5 millimeters, okay? Because it's only until the halfway, if we look back over at our diagram. Only to the halfway, so that's 7.5 millimeters. Okay, so with that being said, so that's an S. We can use Pythagoras to find what S is. So start off by writing c squared is equal to a squared plus b squared. Okay, with that being said, we can now write. So my hypotenuse is the side that's opposite the right angle. So S squared is equal to 7.5 squared plus 23 squared. Okay, so S squared is equal to 7.5 squared. So if I'm doing 7.5 squared, 7.5 times 7.5 plus 23 squared, and that gives me 585.25. Okay, so that's doing that one. Now to get the S by itself, because that's a really big number, so remember that is the squared, so to get the S by itself, we're going to take the square root of that number, so 585.25, and putting that into my calculator, we get that S must be equal to 24.2 millimeters, and that's correct to 1 decimal place. Okay, so that's it. That's the slant height there. So again, by just identifying where that right angle triangle sits, we can use Pythagoras, which we've been doing for the last few topics now, last few lessons, just to identify what that is. Now the last question is a little bit different. It's more of a wordy type question, but thankfully we've been given a picture. So we're going to find the length of the longest rod that will fit inside the cylinder with diameter 5 centimeters and height 20 centimeters. So that's talking about the cylinder. So diameter, so let's use the bottom. So here's the circle here. So cylinder, the diameter is the whole length across, and that whole length, so I'm going to draw the length on the outside of the cylinder like this. That whole length there is equal to 5 centimeters, and the height is just how tall the cylinder is. So it's not the length of the rod, it's the length of the cylinder, 20 centimeters. Okay, and we need to find the length of the longest rod. So let's call this rod, or R. Now, can you guys see where the right angle triangle is in this one? Well, in fact, it is if we use the whole of the rod this time, plus the height of the triangle, plus the diameter. So we can do that, and that makes a right angle triangle like that. So drawing that on the outside, so height, length, or diameter, and length of the rod. Okay, so putting some values in, we've got R, we've got 5, and we've got 20, and that's in centimeters. Okay, now using those values, we can now use our Pythagoras theorem. So c squared is equal to a squared plus b squared to find what the value of R is. So our hypotenuse in this case is the R. Okay, so the R in this case is the one that's opposite, so I'm going to put that in. R squared is equal to, now it doesn't matter which ones I put, which order I put these ones in, it's going to be 20 squared plus 5 squared. Okay, so R squared is equal to, so 20 squared is equal to 400, and 5 squared is equal to 25, so it's 425. Okay, very big number, but remember that's the square, so we need to find what r is by doing the square root of 425, which is the exact value, or the third. Okay, and we want to find, and because we're finding a length of a rod, it makes sense to answer as a decimal. So we're going to actually do that, the square root of that. So the the rod, is equal to 20, and we'll round it to 2 decimal places, which is 62 centimeters. Okay, so the rod is equal to 20.62 centimeters. So it's not actually that much bigger than the actual height of the thing, but still big enough so that it'd be sticking out if you put it straight. So with that being said, that's it for this topic. Again, it's just applying that Pythagoras theorem that we've done in the last few lessons. Okay, and with that being said, I will see you guys in the next loud noise, in the next video.